Good morning, students. Continuation of the previous topic problems. 28th question. A glass prism is kept in water. Glass prism is kept in water, as in figure. N glass is given as N glass. Refractive index of the glass is 1.5 and refractive index of the water is 4/3, means 1.33. 1.5 you can write as a 3/2. A light beam incident normally on face AB. Light is falling like this. Beam means actually collection of the multiple parallel rays is called as a beam. Many rays are there, one light ray is enough for us. So light ray is falling here like this, and the question is that it has to reach the point BC after total interreflection. Condition for the TIR is that angle of incidence should be equal to critical angle. This I equal to theta it becomes here. For geometry can prove that this angle of incidence with respect to normal and this angle will be equivalent. I is equals to theta, but this theta, if it is theta C, if it is theta, if you are taken for theta C, then the light ray simply grazes the surface. For that purpose, you take the critical angle conditions. Light travel from glass to water, means denser rare medium one condition, and the angle of incidence should be greater than critical angle to reach the other surface here. Any angle just greater than critical angle, the light ray simply becomes equal to angle reflection takes place, 2IR, means angle of incidence becomes equal to angle of reflection. This also becomes equal to I equal to R. But the minimum condition we take is for critical angle. If I is equals to theta C. One more thing is N water. N water is 4/3 and glass refractive index in glass is 3/2, which is 1.5. This you have to note. Answers are given here. If I is equals to theta C, critical condition, that is for the starting of the total reflection, what I get here is sin I is equals to theta C if condition, that is supposed to, but is given as, and here in this diagram I is equals to theta, angle of incidence. So what I get the relation is sin theta C is nothing but equal to N water, rarer medium refractive index by denser medium refractive, that is glass. N water is 4/3, glass is 3/2, which is 8/9. So this theta C, if it is equals to theta C, it should be 8/9, but we have got the angle is equals to theta. But for theta is greater than theta C, light reach BC perpendicularly, normally we can say, because total reflection takes place. The light ray reflects by 90 degrees in this case. Angle of incidence equal to angle of reflection, it becomes BC. For that purpose, theta should be greater than theta C. Then automatically sin theta is greater than sin theta C. You have to take. This is the minimum condition. This is for the given conditions, specific cases. So what you have to take is sin theta should be greater than sin theta C, which is supposed to be equal to 8/9 values for the light to reach BC. Next, 20, 1 plus 9, 30. This 30th question is not for CET, it is only for NEET and JEE only, not for CET, but CET students also can have a look into this to analyze the problem. NEET and JEE, some problems take more than 3 steps. For the CET problems, we don't take more than 3 steps, only less than 3 steps we must be able to work out. Here in this diagram, a parallel beam is incident on the prism, as in figure. Beam of light. A parallel beam of light is incident on prism. Is incident on prism, as in figure. As in figure. Find the angle between emerging rays. Find the angle between emerging rays. Given refractive index of that material of the glass. Prism material refractive index is n is equals to root 3 by 2. Whole root, please careful with this. Whole root by 3 by 2. This is for prism material. Find the angle between emerging rays. It is not a Fresnel biprism. Fresnel biprism has very small angle here, refracting angle, but here angle is given as 45 degrees. It is symmetrically given 2 parts. For Fresnel prism, it is less than 1 degree. Each ends. Light rays falling here normally. Here also falling normally, symmetrically we are taking approximately, and instead of going straight term, it will light triangle. Normally in the first surface is not deviated by, because I equal to 0, R equal to 0 it becomes. This n of the glass is given for us, and we will take the normal here. This is normal. Instead of going straight, it deviates. Light traveling from denser ray medium deviates away from normal, so it will go like this. And this axis we can take for the prism will be going to meet here. This is a light ray going to meet. Same thing happens other side also. It is also going to meet here. This is the angle of incidence. This is going to be total value. This is supposed to be equal to angle of refraction. This is going to be angle of deviation. I will take it as a delta. This horizontal inclined line. So what to get the relation is, this is also horizontal inclined line. This is also supposed to be equal to delta. This is also supposed to be equal to delta. You are asked total angle 2 delta is equals to angle of the emergent rays meeting point. Total angle is how much is the question for us. So these are incident ray. This is also delta, this is also delta. Instead of going, sorry, this is delta. N glass, this is N glass or N material. For the first surface, I equal to 0, R equal to 0. On the second surface, you take refracting surface. This is going to be the angle of the prism. So this is 90, this is 90, this is 90, 45. Total angle supposed to be, internal angle supposed to be equal to 180. So for the second surface, what is the angle of incidence? I becomes equal to 45 degrees. I plus 45 plus 90 equal to 180. Therefore, I is equals to 45 degrees angle of incidence. Then apply the Snell's law to find out the angle of refraction. Sin I by sin R is equals to, this is the second surface. Second refracting surface. Sin I by first surface, I equal to 0, R equal to 0, I1 equal to 0, I2 equal to 0. so don't consider it. You can this is one you can take it as I1 R1, I2 R2 also if you want you can take. Sin A by sin R equal to N2 by N1. This is N air. This is N glass. So at this point the second medium becomes equal to N air by N glass. You have to be careful with this step. N air by N medium or N glass if it is made of glass. Not mentioned specifically, we are taking it as some denser medium as a glass. So is equals to 1 by root 3 by 2, which is root of 2 by 3 it becomes. I is equals to 45 degrees. That means sin 45 by sin R is equals to root 2 by 3 whole root it is. But sin 45 is 1 by root 2. We want sin R. Sin R is equals to sin 45. Okay, we can tell is this 1 by root 2 by sin R is equals to root 2 by t. Sin R becomes equal to cross multiply this 1 by root 2 into reverse of this, which is equals to root 3 by 2. Now 2 came out of this root, so R was supposed to be equal to sin 60 is root 3 by 2, R equal to 60 degrees. But we want to find out the deviation. What is the deviation is equals to light travel from density rate means R is more than I, so deviation is R minus I. Deviation delta is equals to R minus I, which is 60 minus 45 equal to 15 degrees. This is not the answer. What they asked is, what is the angle between the two emergent rays? This is for one ray. For two rays, angle between two emergent rays. Is equals to 2 times delta, which is 2 into 15, which equals to answer is 30 degrees. Dispersive power questions are there. I am going to discuss the dispersive power later. It is not for the CET. Dispersive power is not there for CET. It is only for JEE, main and advanced. NEET also they may ask, no guarantee of that. But the CET is not there. Dispersive power is not there. Sorry, 32. These important ones for all exams. CET also important. But 1 minute. In this, they may ask CET, but you don't, without problem solving, you have to work out. It may be asked in the different ways. Two cases it was asked previously, but it was previously asked for JEE. AIEEE. You are given the rectangle prism. This is 90 degrees. This is 45 degrees. And 3 light rays are falling on it. Red, blue, green. Parallel beam of light rays separately falling on this prism normally for the surface. I will take this as A, B, C. This is a red light, blue and green. You are given in figure refractive indices, refractive index values for the red, green and blue. Indices. N red is 1.30, N blue is 1.44. Sorry, this is a green. N green is 1.44. N blue is equals to 1.47. This is a red, green and blue. Which color is separated from the remaining? Is separated from remaining colors. In this case, whenever the light falls on the prism, this 45, this 90, so this is supposed to be equal to 45 degrees. Without mentioning also, you check it as a 45. So light is falling here, normal is here. The light ray incidenting with respect to normal given is equal to angle of incidence. If angle of incidence is equal to critical angle, light ray grazes the surface. It grazes the surface, that is along a AC, it comes along like this. If I is less than theta c, critical angle, it refracts, means second medium it goes. If I is more than critical angle, then if I is more than critical angle, total internal reflection take place. Minimum condition is equal to, but coming back to the angle of incidence, completely coming out of the surface into the same medium is taking place at a TIR. In such case, the reflection means angle of incidence becomes equal to angle of reflection. So I becomes, in this case, I is equals to 45 degrees. And incident ray becomes equal to perpendicular to this is going to be reflected, right? If condition is that I is greater than theta c, that we have to check up for which light waves it is acting like that. For theta is here, I is given as equals to 45 degrees. Already I is given is equals to, from figure, I equal to 45 degrees. So if you take that as a conditions for the critical angle, you have to take this as a critical angle for each one. You have to calculate what will be the values. Theta c equal to how much? Theta c red, theta c green, and theta c blue equal to, we have to find out. How do you find that relation? Is sin theta c, critical angle I am telling, sin theta c is equals to 1 by refractive index. So if you take for the red, n red you have to take. N red is nothing but equal to 1 by 1.3, which is 10 by 13. And if you take sin theta c of green is equals to 1 by n green, 1 by 1.4, which is equals to 100 by 144. Next is sin theta c of blue light is 1 by n blue, which is equals to 1 by 1.47, which is 100 by 147. You don't have to work out again, you need to know the values directly for these three. Always you will find the values for this theta c. After calculation what you get is I is equals to 45 degrees. If I have taken that I is equals to theta c, if I have taken, what to get the relation for the tan sin 45? Sin 45 equal to 1 by root 2. So n becomes equal to 1.414. So these two cases, if I is equals to 45 degrees equals to theta c, then sin 45 is equals to 1 by n supposed to be for the critical angle conditions. That is n becomes, this is equals to 1 by root 2. So n equal to, n should be 1 by root 2 means 1.414. If the angle is more than this, automatically take the total internal reflection. So in this case, which is having the more values is green and blue, exceeding these values. But red is not exceeding values. In that case, red do not take the total reflection. Red goes into the second medium but deviates, of course. This is the red light. But remaining all colors will be taking the total internal reflections. So this is blue, this is red. blue and sorry, this is the green. Red will be going out. Red goes out, blue and green will be separated. They will ask you which color is separated. Diagram sometimes they will give, may not give. But just no need to work out again, please. Always remember there will be a right angle triangle. In that cases, red will not be taking the total reflection because for that angle of incidence is less than the critical angle, and refractive index also less than required values. So higher values will be taking the more refractive index, more the material. Light rays with the higher refractive index, blue and green, take the total internal reflection. More refractive index, less critical angles. The calculations will be getting for you theta c. This will lead to theta c of red is nothing but equal to 50 degrees, and for this theta c of green is equals to 49 degrees, and theta c of blue is equals to 42.84 degrees. Only red will be separated from the remaining two, that you have to remember. Next 24. This is basically concept question but very important ones. And this diagram problem may be asked for CET also, previously asked once I think, but you must be able to work out whether CET asked or not also. You need to work out that. Next 33. A prism can produce a minimum deviation delta in the light beam. If three such prisms are combined, the minimum deviation produced in this beam is, what happens to the minimum deviation? A prism can produce a minimum deviation of delta in the light beam. This is a prism, for example. All symmetrical prisms. Let us take the equilateral prism, for example. This is going to be the angle of the prism. Light ray is falling here, going through this and coming out. This is going to be the minimum deviation. Light deviates towards the base. Deviation is delta. You are taking one more prism. If you take the identical prisms kept reversely, same identical means same materials and same angle also, then it's just like a parallel sided glass slab. In the case of the parallel sided glass slab, if the light falls, it simply goes like this. If the inclination light falls with some inclination, if light falls from inclination, then what happens is light deviates towards the normal, falls here, deviates towards normal, take the normal, light deviates away from the normal. The light ray is supposed to go straight like this. It deviates and comes back parallel to the incident light ray. There is no bending of the light rays away from the initial directions. There is no deviation, please. So deviation becomes equal to 0. If you take the two prisms, identical prisms, kept one after the other in touch, or with a gap also a little bit, some cases given, light ray will not be deviation. Deviation is 0. What about the light spreading out? So if the one prism, if you have taken light, white light can split into 7 colors. Here 7 colors are again recombined in the second prism, and deviation will be towards its base. This deviation is downwards, this deviation is upwards. The resultant deviation is 0. If you take the two prisms bending down and again up, it is supposed to go straight like this. It comes out and comes parallel to it, but not along the same line, deviate by some angle, but some side. This is called a lateral displacement or lateral shift, it is called as. Lateral shift takes place but not a deviation. Deviation is 0. In this case, condition is that the mediums outside the prisms of left and right should be the same material should be there, same kind of medium should be there, air or water, whatever you take. Here one more prism is also kept again. In this question they said that 3 prisms are kept one after the other. One prism produces a deviation, second prism cancels it, third prism you have taken. Then that again produces the deviation. So final prism is nothing but equal to having the deviation equal to delta only. If you take that 2 even number cancels. Odd number if you take any number again produce the same value of the first prism only. If you take the equilateral prism 60, 60, 60. But if you extend this further, it becomes like this. This is also again one more 60, this is 60. Again A only you will get, and you are using the part of the prism. Any part of the prism you are using, it behaves like a total prism only. So 3 prisms if you have gotten, you will get the deviation equal to that of the single prism. But 2 or 4 like that if you have taken means deviation is 0. Next 34. 34 is important for all exams. It is a simple one, of course. Prism having the refractive index, ray of light incident on equilateral prism in such a way that the angle of incidence is equal to angle of emergence. It is equilateral prism. Equilateral prism means angle of the prism is, or reflecting angle of the prism is 6 degrees. Angle of incidence is equals to angle of emergence. Angle of incidence equal to angle of emergence, which is equals to angle of incidence equal to angle of emergence, which is equals to 3/4 of the angle of the prism, 3/4 of A. Equilateral prism, in this case, angle of prism A equal to 6 degrees. So we can calculate 3/4 of A means it becomes equal to 45 degrees. You are asked to find the angle of deviation. Whenever the angle of incidence becomes equal to angle of emergence, that condition is for the minimum deviation position. This is the angle of incidence, normal, going here and again coming out. This is normal. This is the angle of emergence, E. This is I1, or you take it as I only, that is left your choice. Supposed to go straight like this. This is going to be deviation D. If D is equals to minimum deviation, then I1 is equals to I2. That is what is given here. 3/4 of the angle of the prism. Answer A is 6 degrees, I equal to E, I1 equal to I2 is equals to 3/4 of A, which is nothing but equal to 3/4 into angle of the prism is 6 degrees, which is equals to 45 degrees. Next, deviation comes. D is equals to I1 plus I2, or emergence angle E we can take, minus A. Here D equal to D minimum, since I1 equal to I2 is equals to 45 degrees. So this becomes equal to deviation, minimum deviation becomes equal to minimum deviation. dm is equals to I1 is 45 plus 45 minus A is 60, 90 minus 60, which is equals to 30 degrees. That is the answer. Next question, 35. This is also very important one for all kind of exams. A prism having the refractive index, it is a prism n equal to √2 means 1.414. Refracting angle is A equal to 30 degrees. Has one refracting surface is polished. One surface is polished. That is the refracting surface on which the light ray is trying to go out of that surface. Incident light ray retraces its path from this surface. Beam of light incident on the other refracting surface will retrace its path.